Hello everyone. Today we will discuss the question number of islands. This question is asked in Google about 25 times uh, in last 3 months and 5 times in Microsoft in last 3 months. So let's read the question. Given an uncrossed and 2D binary grid which represents a map of uh, one's one's land and zero water. Return the number of islands. An island surrounded by water is formed by connecting adjacent lands horizontally or vertically. You may assume all the edges are surrounded, all the edges of grid are all surrounded by water. So, uh, huh. So what it is saying ki, we will be given a matrix of size n cross n, which will consist of 1 and zeros, where 1 means land and 0 means water. And it is also saying that key edges are all four uh, edges of the grid are surrounded by water. Means if this is a matrix and these are the cells, then it is saying that key around this matrix all are water. And if it is 1, this is land, and if it is 0, means it is water. Okay. So let's see the example it discuss. Okay, so we have to return the total number of islands we have. Okay, return the number of islands. Yeah, so let's see the example discuss. Yeah, so in this example, you can see that this is one island and all remaining are water. So here output is 1. Now let's see the next discuss. Yeah, and here you can see this is one island. Uh, Another is this, and another is this. Yeah, these all are not a single island because it is saying that connection between the islands should be vertical or horizontal.
I have trouble understanding right now. Please try a little later.
Sorry, my Alexa spoke. Yeah, let's continue. So here, so output of this is 3. Now let's discuss the approach. So to solve this question, we have two approaches. One is DFS and another is BFS. And one more approach is there, which is using union find. This is a bit complex. We will be discussing only these two approaches in this video. Okay, so let's start with DFS. So what we will do, we will start with the index. We will start DFS with the index where it is 1. Okay, we will have a DFS function. Okay, so we will start with suppose we started with this index. This is 1. And so we will run a double for loop for visiting each cell to check whether it is 1 or 0. And we can start DFS from there. So if I started DFS from here, what we will do, we will mark this index as 0 as a sign that key we have visited, or we can use some other also like -1. But we can use 0 as it will be convenient as considering that we have visited. So after that, what we will do, we will we will traverse all the adjacent cell of the current cell. So adjacent cell is this and this. So I will make a DFS call to this cell also, and this means all the adjacent cells. So currently these two are adjacent, so we will call a DFS on these two. So suppose if I do a DFS call on this cell, now standing at this cell, I will first I will mark this at 0. That key it is visited. Now again I will check adjacents of this cell. So adjacents are this and this, and this is adjacent, but it is already visited. Okay. So in our DFS, we will add a base condition that that key index is not out of the bound, and the and on the index means on the row and column on which we are calling the DFS, it should be 1. Means it should be a land, not water. So if I'm standing at this cell, so adjacent to this is this and this. These are 1. So I will do a DFS call. If I will do a DFS call on this, this is we have already marked it 0, so it will not do a DFS call on that. Okay. So again, I will mark this as 0, and I will repeat the same. I will check the adjacent cell of that cell. So it is 0, it is 1. Again, I will start a DFS on this. So adjacent to this is this and this. I will mark this as 0, and again I will go to this. Again, I will mark this 0, and I will check the adjacent cell. Adjacents are 0, so no DFS, no more DFS call. Now it will return back. So it will go to now this cell. Again, it will mark this 0 and do a DFS call to adjacent cells. If it is 1, so it is 0, it will not, it will return from there, and it is 1. So it will continue DFS from this. It will mark it 0 and see the adjacent cell. It is 0, it is 0. So it will not go there. It will see, it will go to this adjacent cell, which is 1. So it will again mark it as 0 and check the adjacent cells. Adjacent cells are already, means some of them are water and some of them are already visited. So in a DFS call, we can see that all are marked 0. Okay, so whenever we will do a DFS call, now we will keep a count variable and we will keep increasing. Okay, now if in the for loop, now going back to the for loop, we have started from this cell. Okay, DFS call ended, and we have marked whichever means whichever part of whichever cell was connected to this is marked as 0. Now, when it will start with the next, means this in the for loop, next element will be this. It will start DFS from there, but it will see that it is 0, so it will not start. In this way, it will move to this cell in the for loop. In this cell, it will say 0, 0, 0, 0. It will not start. So we did only one DFS call. So our count will be 1. So in this case, our answer will be 1. Now let's check it on the next test case. Okay, so here also in the for loop, we will start where it is 1. The first index is 1. We will start a DFS call. And after starting a DFS call, it will mark this 0 and check the adjacents. Again, in the adjacent, it will mark the current cell 0 and check the adjacent. Adjacent is 0. This is 1. So it will move to this, mark this 0 and check the adjacent. Adjacents are 0, 0, 0, and this is 1. So it will go there. It will mark it 0 and check the adjacent. No one left. So in one DFS call, we are able to mark all this for us visited, and we are having our count as 1 because we made a one DFS call. Now, okay, now DFS call for this cell ended. Now let me make it clear. So this is also 0 because we have marked this as 0 in the DFS call. Okay, Now the for loop that we are running will increase. Will go to this cell. So this is 0. It will not start. It will not do the DFS call. Again, it will go to this, not a start. It will not do a DFS call, not. Again, it will go here and will do a DFS call. So our count will increase 2. So it will start DFS call on this. So it will mark it as 0 and check the adjacent cells, which are already 0. So no more further DFS call. So this is also marked as 0. Our count is 2. Now it will now the for loop will move ahead. So it will go to this. This is also 0, 0, 0. Then finally it will go to this cell. So it will start DFS call from this cell. So it will mark it as 0 and check the adjacent cell. And also we have started one DFS call, so it will increase the count, which will become 3. So the DFS call will go to this and will mark it as 0. And yeah, so all no more further DFS call. So it is completed and our for loop also ended. And we are left with our count as 3, which is our output. So this is DFS. Let me explain you the code. Yeah, so I have made a recursive function for DFS, which is solve, where I'm passing the grid and the row and column indexes, and I'm running a double for loop, and I'm checking wherever it is 1, I'm increasing my count and doing a recursive call, DFS call, and in my DFS call, I have given a base condition that x should not be lesser than 0 and x should not be greater than the grid of size. Means it shouldn't be out of bound, and it shouldn't be 0 also. If it is 0 means it is a water, and no need to do a DFS call. Okay, so after that I'm marking the current coordinate as 0, means visited or as water. And after that I am doing a recursive call in all the 4 directions to the current coordinates. And it will repeat the process. It will go to the adjacent cell and it will mark it as visited and will return back. In this way, whatever will be connected to that coordinate, it will mark all those as 0. And yeah, after that it will return, and this for loop will continue, and our count will increase and give the result. So this is the DFS approach. So let's run this code. Yeah, it passed the given test case. Let's submit it. Yeah, it passed all the test cases. Now let's see the BFS approach. Let me copy and paste the BFS code. Yeah. So this is the BFS code. Let me explain you the BFS approach. What will happen in case of BFS? So in case of BFS, we will do the same. We will run a double for loop, and from each index I will start a BFS. Means the logic is same. The difference is the way we are marking the adjacent cell as visited. In DFS, we were going into the depth like this. Means going into depth and marking it as visited. In BFS, we will move breadthwise. Means if I'm here, then I will move to this cell and mark it as visited. And after that, I will move to this cell, and this cell, and mark it as visited. So yeah, in this way, it will mark all the cells as visited. So let me explain you indeed. So I will start from this cell. What I will do, I will take a queue. In that queue, I will push the coordinates, of this cell. So this is 0, 0. Now I will run a while loop till this queue is not empty. So inside that while loop, I will pop one element and will check. We'll get the coordinate of the cell. So this is x and this is y. So what I will do, I have a coordinate. So I will check all the four directions of this. And if the adjacent cell value is 1, then I will push that into my queue. So looking at this cell, you can see that this cell and this cell has 1. So what I will do, I will push 1, 0 in my queue and 1, 0 and it will be 0, 1, 0, 1, 0, 1. Now we have processed this index. Now we'll pick another element from the queue, which is 1, 0. Again, x is 1, y is 0. So I will check all the adjacent elements of 1 and 0. 1 and 0 is this. So all the adjacents of this elements are this and this. Again, I will push the adjacent element in the queue if it is 1. Okay. So our queue will have 1 and 1 and another element is 2, 0. 2, 0. So also I will mark that whatever index we are processing, we will mark it as 0. So we have processed this, so it will be marked as 0, and we have processed this. Okay, now next is 0, 2. Next is 0, 2. 0, 2, sorry, it should be 0, 1. 0, 1. Yeah. So 0, 1 is this. 0, 1 is this. We will process it. 0, 1. We will mark it as 0 and check and push all the adjacent which is having 1 into the queue. So this will go into the queue and this will. Okay. So in this way, we will mark this all one as visited or 0. Okay. So after this, our BFS call will end and more and all the cells which are the part of the island will be marked as 0. And again, we will have a count variable. Whenever we are doing a BFS call, we will increase that. Okay. So now let's discuss the code. So yeah, here you can see that we are running a for loop, and if it is 1, then we are increasing count and doing a BFS. Now let's check the BFS code. So in BFS, we are taking a queue, and what we are doing, we are pushing the index into the queue from where we will start. And inside the while loop, I'm taking out that index. Okay, and I'm running a for loop 4 times. This is for the 4 directions. And you can see I have made the 4 directions, which are 1, 0, minus 1, 0, 0, 1, and 0, minus 1. We will simply add this direction, means directions to my current index, which will give all the 4 adjacent indexes or coordinates to that current coordinate. So I am calculating this what the next index is, which by adding the dx and dy to the x and y, previous x and y. Okay. And also checking whether it is greater than 0, means it is not out of the bound, and it should be 1. Then only we are pushing. And before pushing, we are marking it as 0. So, and each time we are whenever we are doing BFS call, we are increasing the count. So that will be our answer. So let's run this code. Yeah, it passed the given test case. Let's submit it. Yeah, it successfully passed all the test cases. Thank you for watching.